Oh my goodness, we did it. Oh, buddy. Woo! That was hard. How many of you remember when Apple could design things? Me either. Yeah, no, I couldn't get on the Wi-Fi. I have one of these newfangled MacBook Pros, and I bought it because I rage quit like the OS X Mac ecosystem in 2016, end of 2016 or early 2017, because I was thinking I want a computer that I could develop software on, as opposed to one that has less RAM than some Android phones. And just saying, you know, just realistically, 2018, not enough, right? So I rage quit. I went back to Linux, and I was happy for a good old year and a half. And then they just released this newfangled MacBook Pro with 32 gigs of RAM and you know, all the toppings and SSD and all that stuff. So it's like, okay, I'll try that. I'll give that a go. So I went and I bought that, and that's what we're using. And yeah, for those of you wondering, 32 gigs of RAM on the Mac, it is just enough to, it's just enough to run Chrome and Slack. So you'll be fine. It's just enough. Now, don't try and run a container or any other thing at all, but you can do both now, finally. So anyway, it's been okay, except that sometimes it's not so great at like Wi-Fi. You know, I haven't been able to connect to Wi-Fi reliably in the couple months I've had it. So that's not good. But I have a dongle connected to another dongle now, in order to make this work. We are connected to Ethernet, and that's embarrassing. So anyway, friends, thanks for joining us today. How are you enjoying the show? Yeah, the people that put on this conference they've grayed their hair in the months preceding this event. Like, it's just insane, you know. They do such amazing work, and it all comes together really smoothly. And the last mile is just, you know, mind competent trying to get on the Wi-Fi, basically. But everything else is just smooth as can be, so that's amazing. Glad you're all here. We have a lot to cover, don't we, my friend?
Oh, yeah.
I'm Josh Long. It's so nice to meet you. So nice that you're all here. I'm a Spring developer advocate on the Spring team. I'm on Twitter. I'm always curious about this. I'm always curious. How many of you are on Twitter? Just curious. How many of you are on Twitter? 2018 Twitter. Twitter. All right, the rest of you, get on it. What are you doing? It's a great place to be. It's the new IRC. It's where the developers that drive the open source that powers your business are. So if you want to engage, as well you should, then find us on Twitter. What about email? How many of you are on email? How many of you have email? Anybody? I'm just curious. Just curious. Oh, okay, very good. A little bit about myself. A Spring developer advocate. I've done a whole bunch of videos on Safari. You can find those. I've got one on Spring Security with Rob Winch, Spring Security lead Rob Winch. That's not listed here, but it's, you know, minutes, if not weeks away from being done. And I've done books. So I've got these books called Cloud Native Java. Been translated into a couple of editions. There's a Korean and Chinese version that I did with my buddy Kenny Bistani. And of course, right now I'm working on my latest and greatest book called Reactive Spring. And this book is all about, guess what? Yeah, exactly. Yeah, not really much of a story there. It's just what it is. So there's that. And I'm joined on stage by my good friend, my hero, my fellow Spring developer advocate.
Mario Gray. How are you doing? My name is Mario Gray. I am the developer advocate for Spring at Pivotal. I am the guy who came in last year, so I'm brand new here almost, but about a year old. And this is my first Spring 1P. This is amazing. This crowd is very nice. You guys are amazing people. Give yourselves a round of applause for the crowd. I'm very glad to be here with you guys. I'm going to talk about, you know, Spring with Josh here. Let me give you just a little bit about my past. I've worked in many industries, many fields, video games. We're talking banks. We're talking, you know, finance, all sorts of. I spread the gamut of what Spring can do. So I've seen a lot of these integrations happen in real time, and I've been there to help organize and enhance change at organizations. So what I come here and I bring to the table at Pivotal is my experience, along with working with guys like this. I'm able to put that together and make it outreach very far. So I hope to give you guys a good message about how to do the reactive testing and to understand what this means in terms of your application from the ground up.
Woo! All right. Well, good stuff. So should we get started, my friend?
Let's get started.
Okay, so my friends, let's establish why we're here, right? We're going to talk about testing, but in particular, before we do that, we're going to do this all in terms of reactive testing. right? That's the main thrust of today's discussion. So how many of you have kind of gathered that testing is kind of important thus far? Yeah, right? So we're doing continuous delivery. The goal here is to support this constant promotion of business value into production, to see the results in production. Right? I want to see the sort of conveyance of an idea from concept to customers. That's part one. And then part two, we talk to organizations all these days about reactive programming. And reactive programming is not a new idea, is it? It's a fairly old idea. It's this recognition that the traditional approach to input and output is not particularly good. It's not particularly efficient, especially as we start to move to microservices and to big data, where we start conducting more and more data over the wire. That approach to doing input and output, it has served us well, but it starts to become inefficient in the light of large amounts of data. And the reason this is so is because old traditional approaches to input and output, especially as embodied by the input stream and output stream on the JVM, require that the client block in order for any activity to happen. So we sit there in the thread that we're reading the data from, waiting for the next byte, and assuming that the fallacies of distributed computing didn't apply, assuming that there's no latency and that the internet is completely infinitely fast and all that stuff. Assuming that was true, then this wouldn't be such a big deal. But we all know that those things are not true, right? We know that these things are fallible. There will be network partitions, there will be outages, there will be delays, there will be latency, etc. And so as a result, we sit there often with idle gaps in between bytes, right? We get one set of bytes and then we have to wait for the next set of bytes. And this is sometimes unintentional, and sometimes it's by design. Sometimes we have we have things that don't lend themselves to this nice, natural notion of a stream that's continuous and ongoing. We might have bursts of activity, right? For example, WebSockets. You might have data being sent down to the client asynchronously, contemporaneous with events on the server side. Somebody's typing into a chat message or something like that, right? Or stock ticker updates that correspond to changes in the stock price. These things don't lend themselves to this notion of an ongoing stream of data. We have gaps in the stream of data. And we have potentially large amounts of data, potentially unlimited amounts of data. And so in both cases, we can't really map this new world, this large, potentially unlimited, potentially asynchronous sort of world to synchronous and blocking input streams. And so we look for an alternative approach. And this is not a new thing, certainly, right? Asynchronous I/O supports what we're trying to do. It's a way of saying to the operating system, hey, operating system, here's a file descriptor that represents activity. It's got bytes that are going to come and go. When there's activity, call me back. You, operating system, can manage the activity for me. You can manage the monitoring of that file descriptor. And as soon as there's anything for me to do, give me a notification. But in the meantime, I'm not going to sit here blocking on that thread. I'm going to be able to repurpose that thread. I'll be able to do more work with that thread in the meantime. So this means that I'm only using threads when I have something to do. I'm not actually sitting there just doing nothing, right, in the meantime. And that means I can do more with my threads. I can do more work with the same number of threads on the same machine. Reactive programming allows me to be more efficient with the same resources in the same machine. And we work for a cloud computing company. I don't know if you could tell, but we're quite keen on this cloud thing. It's going to be big, you know? So it would be great if we could just sit here and tell you, yeah, don't worry about it. Just buy more application instances. Scale out horizontally. That's the cure. And, tongue-in-cheek, it works, right? If you want to be able to handle more capacity, add more nodes. And then it doesn't matter how inefficient your synchronous and blocking I/O is. Eventually, you'll be able to address the capacity demands. That said, it's not really the answer you want, is it? So it's much better to know how to do it the right way, much better to know how to be efficient about it. So reactive programming gives us that. It's a type system, it's an API that allows us to write code that maps to this asynchronous world. Instead of saying that we have a finite collection with a finite amount of data, we say we have this thing that'll produce records eventually, asynchronously, and they'll call us back. And that maps to what's happening down in the machine, down at the lowest levels of the operating system, right? This is the reactive stream specification. These types map to this asynchronous world. They let us express our concepts and our ideas, understanding that beneath the covers, there's this sort of different inverted paradigm. No longer are we pulling data out of the input stream one byte at a time. Instead, the thing that's producing the data pushes the bytes to us asynchronously. It's inverted. We're not pulling, it's pushing. So this new thing, this new paradigm, this is the reactive stream specification. And we've got support for all this stuff in almost every tier of the Spring ecosystem. My goodness, you can do, starting with Spring Framework 5, released in September, a year ago, right? A year ago, 2017, we released Spring Security 5, supporting reactive programming through and through. We have a brand new web runtime. We have Spring Data K, the first release of Spring Data to support reactive access and reactive modules. We've got Spring Security 5, which supports reactive authentication and authorization. We've got Spring Boot 2.0, which is released. We've got Spring Boot 2.1 milestones already, and we got Spring Framework 5.1, but we've, these are all original first versions. Spring Boot 2.0 just in March, first version of Spring Boot to support this reactive sort of umbrella sort of aggregation of all these different projects. And then just a few short months ago, we released Spring Cloud Finchley, which supports reactive types as well when it comes to microservices. So with all that, as the backdrop today, we're going to talk about testing, right? How do you test all this? And what happens naturally, what happens logically when you start scaling out into microservices? What happens when your unit test no longer works because you can no longer have confidence in the result of the linkage between one service and another? So we're going to talk about that today, of course, starting at our favorite place on the internet, second favorite place on the internet. First favorite place, of course, is what? Thank you. Good. So let's build a new service here today. We're going to build a new service called the reservation-service. We're going to use the reactive web support. That work? Yeah? OK. We're going to use Lombok. That's to make Java just a little bit less tedious. And by the way, Java 11 dropped today. Did you see that? So when you're testing your business logic, you can also test your JDK code. Just test, in general, whether it runs or not. That's a good challenge for the day. We've got Lombok. We got reactive web support. We're going to use the stub verifier, right? We're going to come back to that in a bit. We're going to come to that in a bit, but we're going to use the Spring Cloud Contract verifier. And then we need some sort of persistence option, don't we? Some sort of persistence choice. And of course, here we can switch to the full version, whereupon we're given a veritable ocean of checkboxes that, were we so inclined, we could elect to add to our application. We have a number of good options here, including this column here. It says SQL. These options, while tempting, are not for us. You see, these things assume blocking and synchronous I/O. There's some hope on the horizon that this will change. Oracle's got the ADBA project. Pivotal have R2DBC, which is also kind of interesting. There's hope on the horizon, friends, but for the moment, realistically, not really an option, right? So let's focus on these NoSQL options. We've got a number of different options here. We've got reactive Couchbase, reactive Cassandra, good choices both. We've got reactive Redis, also a great choice. We've got reactive MongoDB, because when you want to lose your data, and you want to lose it reactively, there is nothing better than reactive MongoDB. So there we go. Check that out. All right. That looks pretty good to me. Am I missing anything, my friend?
Yeah, I got everything set up.
OK, let's do that. We're going to hit generate.
Yep.
And then I'll give us a new project. And I think now that I did the fun part, you do the hard work.
Thank you.
In my downloads directory, yeah, you should be there. And UAO, there you go. Yes.
This is it. All right. Let's start up IDE. What do we start with? How do we do the TDD thing? We talk about creating tests, unit tests first. We want to create a unit test that can actually describe our service, and then we want to go back to production. So we only want to write like a little bit of a unit test, enough for it to tell us that we have a production code to write, right? And then we want to go back to production, write some real code, just enough to say that that unit test works, right? So we're going to do really small increments of coding between production and test.
Can you see the font in the back, my friends?
That is tiny.
Yeah, I'm sorry. My fault, my laptop, I should have thought about that. OK, let's see, 22, 26?
Yeah, it's good.
In the background, who can see it in the back? OK, very cool.
Okay.
OK, this is still going to be small on the left, but we're not going to focus on that too much.
Yeah, you guys don't need to
So
see
you'll,
that.
OK.
Great.
Sweet nectar.
So first thing we want to do is test our POJOs, because we don't have a POJO yet. And in order to do that, what are we looking at here? Let's go to our test. Hi. Oh, that's because you have a different keyboard than I have.
Oh, sorry.
That's fine. So what I want to start with is I want to scrape away these tests, these annotations here. I don't need them.
Delete that one.
Yeah.
The whole test.
And so, yeah, actually.
Yeah. Just delete the class.
Delete the whole thing? Oh,
yeah.
OK. Sure.
The artifact, yep. There we go.
OK. So what do you want to do here? Just like rename that?
Just delete it.
Oh, you want just to delete the whole thing?
With prejudice.
Oh, gosh. OK.
It's the test that's given to us, but it's like the wrong way to start, you know?
Yeah. OK, so let's create a new file. This file is going to be our real test. Where is our Java class? Wow, everything is like set up a little differently. So we're going to call this reservation because I'm going to create a Pojo called reservation. So this will be reservation Pojo test. Simple JUnit test that's going to describe our object and actually let us talk to it and ensure that it comes out constructed and all the fields are aligned with what we want. So what I'm going to also show you is what does come out of the box with Spring Boot, right? So what type of testing frameworks do we get to use? First of all, there's JUnit. We always know that there is assert. So I want to do something like assert not null, right? That's your standard JUnit assertion. And I don't have, actually, I'm writing too much code. So allow me to slow down here. Reservation, which doesn't exist yet. Let's say it's 1 and Mario, right? OK, so I have a piece of code that's like erroring out now. So my first tnet is, hey, write as much code as you can until it fails. So I'm going to do that. I'm going to just implement this class. I'm going to put it in my production folder and say, here is a bean. Now, what I want to do here is I want to actually create my fields first. So I'll do like a private string ID. So this is a Mongo ID, and they're usually hashes. And then I want to create a field, and I want to call that reservation named. That's going to hold the name of the person holding the reservation. Now, I want to use Lombok. In order to engage Lombok, I want Lombok to tell me about what my getters and setters are, and I also want it to give me a constructor and a no-args constructor. So I want all of these things, OK? I want Lombok to code for me. And it's a compile time instrumenter. It hooks into our compile time, gives us our classes. You can do Java P and look at the actual class that comes out, and it's pretty concise. It's not pretty concise, it's very concise. It's better than what I would do, because I would introduce error by introducing my own getters and setters and equals functions. That eliminates the need to worry about that type of variability. So now I have a data class. This is a standard, just create it and oh yeah, so like back in the old days, we used SQL and we have auto-incrementing IDs. I'll just call this 1, and now I can do my assertion. So let's do that. Let's start with a JUnit assertion. OK, and then let's go to, let's assert that, which is our, let's do a Hamcrest matcher. Yes, import. And I want that to be a, let's see, reservation. Oh, actually, that's going to equal ignore case to Mario. And reservation.getName. Ignore case. There you are. OK. Next. So what did I do here? I did JUnit. I did a Hamcrest assertion. Hamcrest are really nice matchers. You can compose matchers. You can do like mini matchers at once. But the thing that I want to show the best framework that I like to use, at least on a daily basis, is assert.j. And assert.j gives me a more fluent style of declaring my assertions. What it doesn't do is it doesn't fix the way I type. So that I need new hands.
You can't necessarily see it up here, but my friend Mario is a full like 5 meters taller than I am, and this podium is actually inclined when you're typing on it. So poor Mario is hunched over it like this as he's typing whereas I have to like reach up.
But this is the natural way of the coder. We've always hunched over the old typewriters days of the old days.
Well, he's doing a really great job. He's holding himself up, basically, in order to type for you all.
Yes. OK, so all right, what did I do here? I just ran down 3 different unit frameworks that I'm able to create assertion frameworks. So I have 1, my EJ unit. I have 2, I have Camcrest. Matchers. Matchers are great if you want to compose your own matchers and lock them up somewhere and create matchers specifically for your classes. You can do that and reuse them. I like that functionality. And assert is a really fluid, declarative way of providing stated behavior. The next thing I want to do is I want to go into, data. So we have the Pojo, and then we have something like a Mongo document system. So what I want to do is I want to test that this data goes in and out of Mongo correctly. And in order to do that, I need to create a new test. I'll call it reservation. This is going to be the reservation document test. And what will allow me to do is describe the run with. So I went Spring for, Spring for JUnit runner. This will do the same thing. Spring runner. There we are. Hi, get in there. Okay, and then Mongo. Data Mongo test. What is Data Mongo test? Data Mongo test is really a test slice. It's a composed test slice. So what it does is it takes our application context that gets started during test time, and it says, OK, I'm going to remove everything. I want to give you a bootstrap context that just contains application context and some Mongo pieces, right? Also, I want to add like a no-op cache layer, because eventually we're going to hit that where we have the caching layer in between our data piece and our consumer, and I don't want it to do anything. So by default, this is set up with cache for no-op, and it's set up with just Data Mongo. Now, what also does this mean? In the old days, I used to use H2, right? So I would have H2 spin up a database, create, destroy it during my test phases. I don't have that here. However, there is a nice plugin called Flapdoodle, de.flapdoodle, and what it will do is it will start up a Mongo instance on another thread, and then I can talk to it. Now, that Mongo instance is ephemeral, so like nothing stays there. That thing just it's there to just test. It vanishes, it comes and goes as it will. So let me add the Flapdoodle dependency to this project here. So this is de Flapdoodle embed. That's the artifact ID, and it is Mongo. That's it. I want to scope it to test. So again, like if I ran the eventual server, it's not going to see my embedded Mongo. It will it'll look for the real Mongo, and it'll probably not work because we don't have one running at this time. Now, if I go back to my document test, now I can start doing things fun. Data Mongo test gives me the ability to create a auto-wired Mongo template. Actually, I want the reactive Mongo template, because I want to talk to Flux and monos as a way instead of the synchronous methods. Hi. Oh, wow. Keyboard stuck. Excuse me. There we are. And then test should store and retrieve. I know these are really very long-winded. So let's create a reservation. Let's say Mongo template dot. Let's say save a new reservation. So I want to place some data in here first and say here, what will this have? Null. I want it to create my ID for me, and I'll give it the reservation of Josh. So that's a Josh reservation. Now, in order to test a stream, I have to introduce a component, and it's called the step verifier. What the step verifier will do is within a composed reactive stream, this will allow me to assert steps within that stream. So as data is coming out from the publisher, I can assert, hey, the next data that's coming out of the publisher is a realized object. It's a reified type of reservation. So I want to state that. I want to say, hey, I want to, first of all, put data in, and then I want to ask the step verifier to tell me that the data that came out, is it the same data that I put in, right? So let's see. Okay, probably, the way you could slice this is many ways, so let's try the simplest way possible. So first thing you want to do is create a step verifier instance. There's two ways of doing this. You can use a create, or you can use step verifier with virtual time. If you have a time constraint, then you can tell it here, create time for me, and let me advance the tick, the counter. In this case, I'm just going to expect that the data that goes in is the same data that comes out. I don't have any time constraints here. And what I would like to do is say expect matches. And then verify complete. So that's a simple expectation. This is probably the most lightest and quickest way to run a step verifier. Just create the actual flow, put the flow into step verifier lazily, and have it expect the data that's coming out of it. When I ran save obviously returns the object type, so that publisher, that Flux publisher, could easily look like this. Okay, so it's the same thing. However, this will get evaluated separately from the create step verifier step. Now let's move on. How do we test it normally? What is the imperative way of testing? That was the assert J in using our imperative object state tests. And we moved to the step verifier for a reactive test. So we're most likely going to stay with the step verifier for now. The next thing I want to test is, I know that data goes in and out of Mongo, but I don't have like a way in my AP.
Sometimes.
See, there you go again. Yeah. Mongo sometimes works. Now remember, this is an ephemeral Mongo server, so it's just like running Mongo in production. So you can obviously just execute Mongo and say, oh yeah, that actually worked. It's not there anymore. It's good. So yeah, I need a reservation. I need a service. I need a repository. Right, so the next thing I'm going to do is start testing what a repository will look like for this, right? So what would I do? I would say reservation repository test, right? Yeah.
Just show of hands, how many of you are using Spring Data? Groovy. Right on.
Wait, how many people aren't using Spring Data? That's another question. Because, yeah, OK, so handwritten queries for the win somewhere. So this is going to be a data Mongo test. Again, I'm using the Mongo test slice. Remember, that just gives me a MongoDB. It doesn't give me any other part of the stack. So what I want to do is now say autowired reservation repository. Oh, wow. Yeah, so we're going to have to create that, right? All right, let's do that. Let's create the class. And in order for this to work, all that I need to do is obviously extend reactive Mongo repository of, let's see, that's a reservation and a string. Is that correct? Is it the ID first? Yeah, ID is second. Great.
I always forget that.
Yeah.
Every single time.
That needs to be an interface. Got it. And so we want a method, right? So we want a method that says find all or find by name. How do we do that?
Name, yeah.
OK, let's do that. So let's call it public flux of reservation. Now this is a data repository, but this is my own element that I'm inserting here, and I want to test it specifically.
Reservation name.
There we are.
Reservation name.
Find by, oh yes, because it's called reservation name. There we are.
OK.
OK. So back to our test. So now that we have a reservation repository, I want to go ahead and I want to make some assertions here.
So you've got this repository, and the repository supports things like creating, reading, updating, deleting, all the sort of CRUD kind of things that you would do with data. You don't need to test that, right? That's already the basic stuff. That's already been written. So if he had just said interface foo repository extends reactive Mongo repository and just left it there and provided no finder methods, arguably why bother? Just it's fine. It'll work. We know that part works. The reason he's writing a test for this is because he's got that custom finder method, which is built on a query that may not match or may not work. It's an assumption, right? So that's why we're writing this test.
did something wrong. That will work. Save, create, expect, next. Oh, it's a void, my bad. Okay. Let's do this. Let's create our publishers like normal. Publisher, reservation, saved. Because somebody doesn't know how to spell. That would be me. And then, let's see, reservation dot, we'll do a flux of reservations. So we'll do find all. Does that work? Oh, then many. Oh, before I did a flat map, right? Then many. Store the publisher as a flux. Where is it? Because it doesn't take flux. Thank you. That's very good. Then create found reservations. And now I can make expectations against it. Matches.
Or maybe just start as a mono.
It's a mono?
Yeah.
Where's the mono? Oh, that's a mono.
Yeah.
Right. Because the save is a mono, right?
So in the reactive streams world, we have two types. We have publisher, which is from the reactive stream specification. That's the base type, but it's pretty bare bones. It doesn't do much. It just publishes. And if you want to work on the streams of data, if you want to operate on it, filter, transform, that kind of thing, you need to use some of the specializations from Reactor, the pivotal project, the open source project that supports these types. And there's two types there that are two specializations. One is called a flux. A flux is a publisher that produces 0 to n records. A mono is a publisher that produces 1 or 0 records, right? So they're both publishers, but they also support operators like filtering, transformation, composition, these kinds of things that go beyond just publishing. And so they make it easier to work with different types of data. If you had, one second, if you had a publisher and somebody asked you to render a user interface, what would you do? Would you render a detail page with the details of one object? Or would you render an overview page with all the records in the sort of search results, for example? How do you know, right? If you get a publisher, it's not really clear which one is which. If you get a mono, on the other hand, you can say, oh, well, that's more like a completable future that has reactive stream semantics. It's going to have one object, right? If you have a flux, it's probably more like a collection. It's an aggregation of a number of records from 0 to n. And so now it's kind of clear. So in your methods, for your services and so on, return mono and flux, but accept publisher. And there's also like a flux.from publisher method, a flux.static method. Yes, sir?
Is the reactive streams API part of the Java specification?
Great question. So the reactive streams types are now part of Java 9. They're not exactly the same, though. So there's org reactive streams dot whatever. Before in Java 9, it's Java util concurrent capital flow, the class, and then inside of that, there's flow.publisher, flow.consumer, flow.subscriber, flow.subscription. And these definitions, package notwithstanding, are one-to-one mirrors of the things in the reactive stream specification. So projects like Reactor have adapter methods that'll take a Java publisher and turn it into a reactive streams publisher, or vice versa, right? Great question, sir. Thank you.
Okay, so that completes the reservation test. What we did was created a reservation, put it in memory, or in that Mongo instance, and then we just got it back out and asserted that was the same thing that we put in. We always know that the ID is going to change, and in fact, the order of the things that we put in to the Mongo, when we do save and we pull it back out, we can't declare that order. So it's just easier to say, okay, well, I'm going to put one thing in, and I'm going to get that same thing out, and then I'm going to test its state. And using verify complete is actually a compound, because you don't have to use verify complete. You could also say, you can say, like, there's two expectations. There's two expectations here. There's verify, so you can say, hey, is this thing like done? Do we have the subscription in signal? And then you can say, is it complete? Which means that we're done with this test. It'll pull the subscription from that publisher, and it'll execute those assertions. And the reason why they have two statements is that you can say, hey, between subscription being complete and us being done, do we want to do anything else? Do we have to do other like logging for your Jenkins build to let it know, hey, this is a part of the test that we're running. So it's a very well-written API. I really like it, and I think you guys are going to like it too. What do we have after that?
Well, we've got a repository. We've got your document test. We've got the POJO. I think we're now confronted with an existential question, something with which I'm sure we all wrestled in university, which is if I write data to the database, but I don't have a REST API by which to read it, did I actually, in point of fact, write the data, right? And the answer is no, of course. You could have skipped that stupid philosophy class. So we need a REST API, otherwise it doesn't exist. So I think that's what we're going to do next. Yeah? Cool. Now, a couple of things about MongoDB. All jokes aside, in terms of the reactive API for MongoDB, they have one of theirs is one of the most sophisticated. In Spring Data Lovelace, which is now GA, as of like last week, I think, maybe it was 2 weeks ago, kind of runs together right before Spring 1, the gravity well of Spring 1. As of last week, that was a GA project. And there you find Spring Data MongoDB supports MongoDB 4, which in turn supports transactions, right? So you can actually have multiple inserts into the database and then put them in a transactional block and then commit all or none atomically. You can roll back based on that transaction. That's a new feature in MongoDB, and that's already supported in Spring Data MongoDB. That's also supported in the Reactive API. So we have a reactive transaction thing API in Spring Data MongoDB. It's pretty cool. Like this isn't supported necessarily in all the other reactive options, and the reactive options aren't necessarily a subset of all the supported MongoDB, or rather Spring Data options. Okay, so we've got this really, really nice set of tests here. We're able to go quick because we wrote tests that kind of confirm what we're doing along the way. And this is all just sort of reading data and writing data to the database, and we've got a good feel for how nice it is that Spring Boot comes prepackaged out of the box with all the different testing libraries that we would like to use. We got a feel for what it is to sort of poke at the database and confirm that we can write data to it and round trip the data and get it back out. We got a feel for what it is to test a repository that has a custom finder method on it. Now we're going to write a REST API. Right now I want to be able to talk to that REST API. So I'm going to create a reservation REST controller test. All right, and that's just going to be a test that interacts with my REST API, which of course we have not yet written. So this REST API, it's going to be let's just create one endpoint just to keep things as simple as possible. I don't want to go too far, too hard, but I do want to, I want to just have a single endpoint so we can demonstrate the basics, And so what we're going to do is we're going to write a test that uses the Spring Framework 5 web test client. And in order to appreciate the web test client, you have to appreciate that there's also, in Spring Framework 5, a web client, a reactive HTTP client called web client. Right? And so this is the sort of test version of that API. Okay? It sort of fits naturally where the mock MVC client might fit in the Spring MVC world. Okay? We want to test in this code here. Wow. Test public void get all reservations, throws exception, and this is going to be an endpoint that just returns all the HTTP reservations using the HTTP get verb. So I'm going to say this dot web test client dot get, and we're going to say, nope. Wow, it is. I'm impressed you were able to do it so well. It's at an angle and it's very weird. URI / reservations. Right? I'm going to say that when I exchange the data, when I make a call to the service and actually start the consumption of the response. So again, these reactive stream types are quite like myself, lazy. Right? They're inert unless you encourage them. And that normally means you have to subscribe. It's sort of like the Java 8 Streams API. There's a terminal method in the Java 8 Streams API that, once invoked, causes the whole pipeline that you've thus far defined to start executing. But nothing happens until you get to that terminal method. So you can write like 20 lines of Java 8 Streams API code and then get nothing because it's not going to do anything until you call that final method. And the same is true for the Reactive Streams API. The Reactive Streams API requires you to subscribe. Okay, so here's why it's important that we say get.uri.exchange. That exchange says, okay, I'm ready now. Go ahead and start conducting bytes over the network through a socket. So I'm going to say exchange, and then when the data comes back, I want to confirm things about the status. I want to say, yes, it's a HTTP 200, it's OK. I want to confirm things about the headers that come back. I want to say that the content type, for example, is application JSON UTF-8 value. Great. I want to confirm things about the body of the result. And so I can say expect body.json path. And here, this is, if you've ever used the mock MVC test support, we have this support in that world as well. Here we can use JSON path, which is a very nice library from JWay. It's sort of like a JSON equivalent to XPath. Now don't cry. I didn't mean to set the mood so low. It's nice. It's not like XPath, in that way. It's not inscrutable. People have survived. So we're going to say @.0.name. Okay, let's see. .name is equal to, and then let's say Mario. Okay? There we go. So there's that. There's our simple test. Now, this is going to be a test as before. It's going to be a test that we run with the Spring Runner. Okay, so this is the thing that teaches JUnit 4, in this case, how to work with a Spring application in the Spring application context, and how to satisfy, for example, fields that have @AutoWired. We could use, and realistically should use, JUnit 5, but as we'll see in a minute, we're going to be using Spring Cloud Contract, and that doesn't quite work with JUnit 5. It's coming, okay, it's coming. JUnit 5 and 5.1 are really, really recommended, so I wholly recommend you use that. And when you use that, basically you use the Spring extension.class instead, and the API is just a little bit nicer in every way. So this is going to be a thing that's going to use the Spring Runner, and it's going to be a web flux test. Web flux test, right, as opposed to the web MVC test. So it's a slice that's going to isolate the things related to the web tier in my application, right? And it's going to ignore all the things that aren't related to the web tier, including, of course, all the stuff that we just did in defining the persistence, right? I'm not trying to test the data tier anymore. He just did all that, right? We know that all works just fine. We just went through that exercise. So that's not the goal here. What I'm trying to test is that if I make an HTTP request to this endpoint, that I get back a thing that has the shape that we expect, and it has the right status code and headers and all that stuff. I don't really care about the talking to the database bit. I just want the actual exchange between the client and the web service to be as predicted. And because of that, I want to tell my code here, I want to tell it to bring in my REST API, and we'll do that in a second. But I also need to tell it that when it calls my data tier, I need to tell it how to do that, because it's not going to know how to inject or use anything from the data tier, is it? So let's go ahead and see what happens. Let's just run this code. We know it's going to fail. Let's just see what happens. So OK. First things first. First error. It's a 200. But we expected a 200, but we got a 404. So I think we can figure out how to fix that. Let's just go ahead and build a simple endpoint here, like so. I'm going to call this the producer REST configuration class. And therein, I'm going to create a bean, and I'm going to define a functional reactive endpoint here. So server response routes, and this is going to be a functional reactive endpoint to a configuration class. And the functional reactive endpoints are going to, I'm going to describe a route through this route mapping, and I'm going to say whenever somebody makes an HTTP GET request to /reservations, I want this handler function to be invoked. And this handler function is going to produce a response. I'm going to produce that response by using my reservation repository, which we've already thus far defined. So I'm going to inject that into the constructor there. There we go. Very nice. Get rid of that. Don't really need that or this. OK, so I've got my constructor. I'm going to inject that into my configuration class, and I'm going to use that here. I'm going to say, OK, well, return a server response whose body is OK. It should be status 200. And then use this dot reservation repository. Or just reservation repository. There you go. Dot find all. And the payload that gets sent back is a payload. It's a publisher of type reservation. Now this is a little verbose, isn't it? So let's clean it up. We can use a lambda. That's nice. I like that. We can use static imports. Static imports. Save the day again. So there we go. So that gets really concise really quickly. Look at that, huh? So that's a one-liner HTTP request, HTTP endpoint expressed as concisely. That should surely fix it, right? But I don't, somehow I don't think it will. Let's see what happens. Nope, still a problem. We got a 200, but it's a 404. So the other thing is we need to tell our code which part of the engine to install. So producer rest configuration.class, import that in particular. All right, now we've got a different problem. It says no qualifying bean of type reservation repository. So again, this is going back to what we just said. This slice is only going to install parts of the application context object graph. All the stuff relating to persistence, it's all been sliced out, so to speak, right? And that makes it much faster. We can just test the thing that we care about. We can test the thing that's under test, isolate the rest. The invariants get excluded. But we do need that thing in order for this code to work, right? I can't make a call to the REST endpoint if I can't inject this repository, and I can't test the REST endpoint if I don't have that repository. So I need to mock it out. One way to do that would be to go to the side. Oh yeah. Ah, very good. Thank you. One way to do that would be to create a object on the side and then use Makito and say makito.mock, and then I could certainly do that, but then I'd have to craft a configuration class that has the bean that I want, and I'd have to selectively bring in that bean and then exclude the other one, and then it would just get tedious. So thankfully in Spring Boot 1.4, we've got this @mockBean annotation. And this mockBean annotation is going to let me tell Spring to either insert an additional object of a certain type, or sorry, to replace an object of a certain type, or insert the object if it doesn't already exist in the application context. In this case, I'm going to tell it to create this object. I'm going to tell it to create a mock of this type, reservation repository, in the context. Now, this is actually, mockBean aside, this isn't actually a mock, is it? A mock is just an empty object that returns null and false and that kind of thing, right? We want something that actually responds with pre-programmed sort of responses. Oh yeah, wait. Thank you. So we want something that returns with pre-programmed responses. So what we're going to do is we're going to create a stub, right? That's the difference between a mock and a stub. So I'm going to use Makito as before, and Makito.when, this reservation repository, find all. And by the way, you can see that here. You can see it's an ongoing stubbing thing, right? So it's stubbing out that bit right there, not mocking it. And I'm going to say then return. And what are we going to return? We're going to return a new reservation 1 Mario. Okay? So there's my bit of mock code. We're going to run that again. My stubbed out code. Still not quite right, is it? Oh, yeah, good catch. Eagle eye audience. Love it. So reservation name, re-go. Good stuff. Look at that, hot sauce. It worked. It's green, it's beautiful. And see how fast that was? 201 milliseconds? Right? That's nice. That's hot. That's like, it's really good, right? That's the benefit of slicing out the thing. I'm not paying the cost of starting up everything, right? I'm just testing the thing that I care about. All right, where are we now? What do we think?
What do we do? We have a website, and now we're ready to compose to make a consumer for it.
Yeah.
We have a producer. Now we have something that actually needs to talk to it.
Right.
For purpose.
You want to take it away?
Yeah. How does that work? So what we're going to do is create the consumer side of this. This is the producer. It's essentially it's our web server. We can deploy it now and let it serve our requests. But before we do that, we need something to read the requests. So let's go on back to Spring, start.spring.io, and let's create an artifact called reservation consumer. There we are. Now we're going to need, not MongoDB, since this is a client, we're going to need both reactive web, of course, we're going to need Lombok, and we're going to need the stub runner, the cloud contract stub runner, which is the consumer side of the producing stub verifier, right? So we have 3 components here, and it looks like we're good to go there. Let's go ahead and generate that. And, oh, hello. Oh, that's odd. Oh, it ate up an entire terminal. Oh, it doesn't even respond to ctrl+z. Look at you. Okay, well, we'll fix that. You should never background a process like that. It just causes havoc on your terminals. Okay, so let's start with our tests again. Now, what we don't want to do is show you guys like what I've already tested. So I'm going to create, just flat out, I'm going to create a data bean that will hold our reservation. And I will call it, well, reservation. That was pretty simple. And because we're using Lombok, we get to shave some time. So I'm going to create a field called private string ID. And, oh, yes. And then a thing called, what would I call this one? Name, yes, that's a good idea. Now, all args constructor is important. I want my no args, and what else do I want? I want data. Data is for getters and setters. That's very important. Okay, next. I have a bean. Now I want to test. What do I want to test? I want to test that web server works. Okay. So Josh, you created a web server, but I'm not going to deploy that web server and start testing it because that's going to require lots of memory. It's going to require me to stand up a whole new production server every time I want to test. That's just not fair. Let's do something better. We can do a little bit better than that, right? So let's delete this guy. Let's go back into reservation consumer, and let's create something called reservation wire mock test. So what we're going to do is mock our service. In order to do that, we're going to use what? Spring Runner, of course. Run with. Hello. There we are. And this will be a auto-configure watermark. So I want to put it on a port. Do we put it on our own port, or do we want to just go ahead and say, let's put it on port 8080? It'll know what to do. So what this is going to do is stand up a wiremock server for this particular test suite. And we want to tell the wiremock server, hey, what's going to be served? In order to do that, let's show you. Let's go into before, and let's say public void setup. And in our setup, we'll say wiremock dot dot expect. Ooh, come on, there you go. No, is this even? Did I not put wiremock in here? Yes, I did. Okay. Dot stub 4. So what I want to do is create a stub. So this service is going to be me describing the actual service. This is the consumer, the guy who's writing an iOS or Android app, creating the service. And you'll see where this falls, right? So I want to tell wiremock here, you're going to expect a get, and then you're going to return a response. And that response has a specific texture to it. It's going to have like, stuff. Basically a header, one of those things, HTTP headers, dot, let's see, charset, what is that? Content type, where's my content type? There we are. And then I'm going to use media types. Dot, ooh, hi, get back over there. Media type, no, not you.
Why is that even there?
I don't know, why do you have
Java
in here?
Come on,
IntelliJ. Media type dot application JSON UTF-8. And then the next thing I'm going to do is say, besides the header, what are some things that usually you get out of an HTTP response, right? Usually a body. And what I'm going to do is parse some JSON. Into this so that it looks natural. I don't have to create like actual a JSON string. And I'll show you how that works by using the auto-configure JSON testers. So I want JSON testers. JSON testers gives me an object mapper, and it gives me the validation stages for the object mapper. I can talk to it. I won't be talking to it in this particular test. However, I will use the object mapper to get data in and out of JSON, right? So let's do that. Let's do auto wired and give myself an object mapper. And now I can say string JSON is equal to what object mapper dot write value as string, and I'll give it a, I could probably make it a list, right? So I'll do arrays as a list, and I'll put a single reservation in there. Hello. and I'll call that one Josh. And we'll let that fly because this guy needs an exception catcher. He's got to throw something in case something's wrong with the JSON or something's wrong with my object. So let's go ahead and look at that again. So we got the setup. We stubbed out our service for a get request to /reservations. We told it to return this JSON blob that contains a list of one element, right? Now I want to test that because this isn't before, and now we're ready to actually test our mocked service. What was the one, did we have a client yet? No? Okay, well, we're going to need a client soon. So let's see. Do we have a client? Oh, gosh. OK, so yeah, I don't have a client. So what do I do for that? So first of all, I wouldn't do that this way. I would actually inject the client because what I want to do is utilize some of the resources that I get from the Spring Boot framework. Namely, I want a reactive client. So I don't have this guy yet, so let's create him. So what we're going to do is create a stereotype of component, and that component is going to contain just the logic that we need for our client use case. And I need the following. I will need, do I have to inject the client?
Yeah.
Yes.
Web client.
Web.
Private final.
Oh, private. Oh, yes. Private final web client. There we are. OK, and I can do that guy here. There we are. Great. Now, let's create a method. Let's do this. Let's make it public. We're going to talk about a flux of reservation. So we're returning a stream of reservations from this client call. And this client, what do we have? What is our current endpoint?
Get all reservations,
all
maybe?
All reservations, OK. So now, the next thing I want to do is say, let's do web client dot get dot URI. And I'm going to hard code the URI in here. Don't do that normally, but it's just we want to be able to save time. Normally, I would inject that. I would use like a value or something. And I'll call it reservations. So localhost 8080 /reservations. And then I'll say here, give me an exchange. And then, hi, how are you doing there?
Flies.
Yes. And then how do I get the body out of this? Body to flux, yes.
Or just retrieve.
Yeah, and body to flux, there we are. Oh, type, reservation class. There we are. Now I can return that. So this is going to, every time I run this, it's going to just return this one stream. It will get every time somebody calls the subscribe on this web client, it will say, OK, well, I'm just going to go ahead and fetch something from HTTP URL, and I'm going to retrieve the body and convert it into a reservation. So whatever the JSON comes out, it's going to come back as my reified class. Now, how do I do that in this test now? So because I have a client in here, I can now do things like step verifier. So I'm going to create the stream, and I'll say client.get all reservations, and then I can say expect next. I could say expect next, but I can also say expect next matches. I'm getting in a habit of using the matchers instead of just the POJOs to build the expectations because I'm able to ask a lot more about what's coming in the stream.
Be fuzzy.
Right? Yeah. OK, so I've created my step verifier, given that client get all reservations call to say, come back with reservations, and make sure that, hey, that Josh is in there, and I have an ID in that as well. Now, if I test this, expect verify complete. There we go. There we are. So I can do expect complete or just verify. Let's try that. There we are. So I talked about this earlier. Expect complete and verify are two completely different parts of the reactive stream assertion. And in this case, I'm just going to go ahead and split them out, and just to make it like succinct. Like, OK, he talked about that, but why didn't you use it? So let's go ahead and do it that way. I don't have to do special things like log, but I can. Not that I'll show that right at this point in time. So that test failed because we have an error obtaining bean of, oh, right, of course, because there is no client. So how do we do this? Let's create a client. Let's create a bean of type client.
Don't you already have it?
No, it needs to be returned.
Oh, for the client, yeah.
Yeah. There we are.
Give the method a name.
Hi. Okay. Okay, now we can run this again. But so what happens is web client isn't there automatically. You don't get it for free. Nothing's free, actually.
So that's the reactive alternative to something like the REST template. Very convenient.
Yeah, the REST template it's exactly the reactive cousin to it. Now, oh, because of the imports. So what we have to do here is say import, right? We did this last time. And I'll say I'm going to import the reservation consumer application.class, and I want to give me my reservation client.class. Now, there we go. So I import both components, make sure the wiremark is turned on with the before, and my client test should just work as it should.
All right.
So that happens to be a standard wiremark test where I'm stubbing it out. But remember, this is the client. You don't want to always trust the client's, like, what's his judgment on what the server should do, right? So how do we fix that? What's the thing about that?
I mean, this looks fine, right? I mean, both sides are green. Both sides are green. It looks happy on this side. As it was green on the producer. Surely we're done, right? Surely.
Yeah, you could call it a day.
I mean,
okay,
we could just phone this in, go home, we can deploy.
Yeah.
We don't even have to look at the results, right? This is fine. Not quite, right? I mean, we're going to run into a bit of a problem here, and the problem is that, well, I wasn't exactly communicative with my buddy Mario here. He and I didn't have that communication meeting that we're supposed to have to sort of establish that the client would consume a payload that had as its field reservation name, not name. Right? The producer is sending reservation name in its entity for reservation. Right? If you look at the producer side, here's the producer. On the consumer side, it's just name. We've got a bug, and yet both sides are green. Right? This is a bug that we would never find unless we did some sort of exhaustive integration test. And there is nothing more unfriendly than having a new employee try and on-ramp into the company, try and on-ramp into the organization, and telling them on their first day, here, deploy this Kubernetes cluster, right? Just before you can start running any tests at all, right? It's very hostile. It's very unkind. And not to mention, it's expensive. It takes forever, right? This is a place where your Mac just can't go, right? You can run Slack, but the whole cluster, no, that's a bridge too far. So we need to be a little bit more efficient, and we still want to get confidence in our tests. I want to be able to isolate my client from the service, like as we did with the wiremark thing here. But I want to have confidence that the client API, the mock service to which we're making these requests, matches the reality of the production service. So in order to do that, we're going to use Spring Cloud Contract and consumer-driven contracts. And Spring consumer-driven contracts give us a way to define the shape of a service and have that turned into a test. It'll be turned into a test on the producer side. So here we are on the service itself, the producer side. And we're going to create a new contract in the source test resources contracts directory, resources, contracts directory. And therein, we're going to create a new file that's a Spring Cloud contract. And Spring Cloud contract will give us the ability to, as I say, describe a test that will get run against our production code first. So let's see what that looks like. I'm going to create a new file called should return all reservations.groovy, like that, okay? And that file is just going to be that. It's just going to be a simple Groovy language contract that I'm going to define. It's going to have a request body, request definition, and a response definition. Think of these contracts as a unit test. Each one of these gets turned into a unit test. And we're going to actually transpile into a unit test. So should return all reservations. I'm going to say that whenever somebody makes an HTTP GET request, I want to match that. Whenever somebody goes to /URI/reservations, I want to match that. And whenever somebody goes to that endpoint, I want to produce a response that has a status code of type 200. It has the following headers, right? I'm going to say that this is the header, application JSON UTF-8 value, right? content type, actually. It's application JSON UTF-8 value. And the body, well, it could be a number of things. I could just do a multi-line string. That's certainly an option. I could say I want the body to have an array of JSON objects, like so. So like that, like this. And I could have ID, question mark, and it'll be just, let's say, 1. And then the reservation name attribute, like so, and Mario, right? So what I'm saying is, I'm expecting that if somebody makes a mock client call using the web test client to our reactive HTTP endpoint as defined in this code, I'm expecting that, assuming it looks like this, I should get data that looks like this, a status code 200 and this body. Well, this body implies that there's mock data in there somewhere, right? That behind the scenes, we are returning data that's been pre-programmed, because obviously we can't just call the production database and expect one record with ID 1 and the result being Mario. So we have to assume that this is going to be turned into a test, but just as before, just as with our other test that use the web test client, we need to have some sort of initialization logic, some basic construction logic. So here in our build, we're going to go back to the build, and we're going to enforce this contract. So I'm going to say plugin, and we're going to use the Spring Cloud Contract Maven plugin to do this work, right? And the Maven plugin is, I confess, just a little tedious. So here we go. Artifact ID, group ID, org Spring Framework Cloud. Artifact ID is going to be Spring Cloud Contract Maven plugin. Is that about right? Looks good. Okay. Version. We'll get back to that in a second here. The extensions, we're going to use extensions true, and we're going to have some configuration, and we'll revisit that in a second. But the version is arguably the most important part. Contract.version. I should just be a little more verbose and useful in expressing my name here, but I'm lazy, so stick with that. Contract.version. And the version for us will be, what did we say? I always get the number confused.
1.3.
So what is it?
It's like 1.2.
No, never trust a build under pressure. So it is
auto-completed as well.
What is it?
Try 1.2.
1.2.0.release?
Yeah.
Is that right?
Go for it.
Okay. What do you have to lose? So there we go. There's that. And it's downloading the world. And this is going to turn our Groovy contract into a test, right? That's going to be evaluated against our thing. So actually here, let me just download this here. Producer, POM, grep -I contract.
So if you have a bin directory, you probably have Spring Cloud Contract Runner.
Version 2.01 release. That's the one I have on my local machine. Mm-hmm. Okay, that's here.
Excuse me, does Spring Boot manage the plugin versions?
For the plugin, no. So you cannot through, Spring Boot doesn't know about Spring Cloud, right? Spring Cloud depends on Spring Boot, so there's no dependencies in Spring Boot. And BOM, bill of material, Maven dependencies, are not able to, for whatever reason, Maven, manage plugin versions, right? They can manage dependencies, but completely bafflingly, they can't manage plugins. So we have to do that ourselves. That's why I'm struggling doing it the old-fashioned way. So, my brain is just so not used to it anymore, right? Okay, so now we've got a configuration, and this configuration, there's a lot of things you can put in here, but what we're going to put is a base class that all of our tests should descend from to have some initialization logic. So I'm going to call this type called base class, right? And I'm going to specify this base class in my configuration here in the Maven build. I'll say it like so. And the base class is going to do basically the same thing as we just saw in the web MVC test. I'm going to say it's going to be a application that has a base, a Makito use case there. So where are we? Base class here, and Spring. Well, I guess webflex test run with Spring runner.class at before public void before, and I am going to same basic thing. We're going to make sure that the mocked injected version of the reservation repository is there. Okay, so there's that. And then the other thing that we need in this case, and the other thing that we need for initialization, is we need to tell our Spring Cloud contract code about the framework, right? So rest assured. So we're going to use rest assured dot base URI equals HTTP localhost 8080. Okay, so there's our basic URI. Okay, so there's the base class, and that's going to return one record called Mario. We can see that we've got this contract that also looks for one record with ID 1 reservation name equals to Mario. Let's go ahead and compile that now. So CD downloads service, and make that a little larger here. Maven clean install. So, knock on wood. Okay, awkward. That gave us an error. And you can see that it's returning an error in this contract verifier test. And that contract verifier test is not something that we wrote, right? We see that that's been generated for us by the plugin. So let's look for that. There it is, cat that file. And there it is, that it's saying, I'm making an HTTP GET request to the reservations endpoint. I'm expecting status code 200. I'm expecting application JSON response. I'm expecting reservation name equals to Mario. I'm expecting the ID equals to 1. And it's extending our base class. And so our base class, for whatever reason, is missing a dependency. And rather than fight with that, I'm just going to use Spring Boot Test and run that again. Yikes. Maven clean install. Okay, what happened there? Missing method invocation before. You know what? Find iname desktop. Whoa. Why did they put that button right there?
Yeah.
Find desktop Bootiful reservation service. So it's a producer and it's iname base class .java. Cat that file. And it looks like this, right? Let's see what we've got. Okay, there we go. I've got a few missing pieces that I could have just copied and pasted, and I should have just done that. So here we go.
Okay.
A little bit better. Alrighty. So that's just a basic test. I'm saying start up in port 0, create a random port, run with the Spring runner, use this REST configuration, and otherwise it's the same as before. So now Maven clean install. Okay, come on. Okay, so it's now giving us a more interesting error. Illegal state. What is the error here? A mock MVC instance. What? Mock MVC? Why would it care about that?
Random port.
Sorry?
Random port. How about in your contract definition?
Oh, in the contract definition.
Copy the contract definition. Yes.
Right. Contract. Well, no, it's the configuration. Test mode. Thank you.
Explicit. Yes.
Yeah, I forgot it. So this is if you're doing reactive. This has to be set here. Otherwise, it assumes Spring MVC, which is precisely not what we're doing. Now, hopefully that name, I'm told that name will be improved shortly. Explicit, oh, for Pete's sake. Let's see here. Cat, desktop, producer. Oh dear, producer, pom.xml. Explicit, test mode, capital letters.
Capitals.
You have to be very explicit.
Very explicit.
About how explicit you are. And apparently that'll be changed, so, you know, enjoy. Ah. What are we missing here, friends? Legal state. Match the JSON. OK, good. It doesn't match. So we said we got 2 records that came back, and the thing is looking for just 1 record, Mario. So where's the difference? Where's the discrepancy here? Our base class is returning A and B. I want to do just Mario and get rid of the second record there. OK, Maven clean install. Okay, great. So now, whoa. Easy there. We got 3 dependencies installed. We got the snapshot jar, we got the palm, and we got a third artifact called the stubs. This stub is a thing that we can use to communicate the contract between producer and consumer. That stub gets installed into Artifactory. So every time you do git push, you go through continuous integration, deploy to Artifactory, deploy to Cloud Foundry. This stub represents the passing tests that you've just passed. It only gets deployed if your test pass. That stub is what we're going to use now on the client, back over here, in the client, to stand up this API here. So I'm going to say, I want to, instead of doing all this wiremark stuff by ourselves manually, I'll just let Spring Cloud Contracts stub runner create that thing for me. Okay, so I'm going to say auto configure stub runner, and I'm going to say I want to use the dependency called com example reservation hyphen service. I want to use the latest version of it, and I want it to run on port 8080. Okay, so it's going to download. It's going to use Ivy. The Java annotation itself is going to use Ivy. And it's going to use Ivy to download the dependency and start up a fake server, just like if we had written the wiremark endpoint by ourselves. But as a result, we don't need this anymore, right? We can get rid of all that. We don't need, well, you don't need that anymore, right? All that goes away, right? So all that goes away. All that's left is this one test. And let's see if that works, right? Oh, it's we're expecting Mario, right?
Yeah.
So there we go. It'll still fail. We know why it's going to fail. And the reason is because it's a null pointer, right? Look at that, null pointer. No, that's OK. Where's the null pointer? It's obvious, right? We're expecting name. We're expecting reservation name, but we got name equals null. So that doesn't work. So obviously, we caught the bug in here somewhere. We have a bug in our code. I think you and I can all guess where. Let's change this to reservation name, right? And this changes as a result. Get reservation name. Restart.
So we kind of outlined, hey, what happened to the producer, right? The producer created one thing, we created another. They were not the same. We had that, we had that variability that we can't control. Yay!
Now, all right. So we have now. There's one last hypothetical here. Hypothetically, and again, I can hear you say, "What the hey? What? This is not going to be a thing." But hypothetically, and I regard this with distinct skepticism, okay? I regard it with the same skepticism with which scientists regarded the possibility of a Higgs boson particle for the longest time. It was theoretically possible, it just hadn't been confirmed in nature. In theory, there could be people not using Spring in Java. And if that's the case, and again, I haven't seen it, right? If that's the case, you can download a jar and point it to the artifact locations, and it'll actually download the stubs for you and just create a mock API. So if you have an iPhone client, they can just download the jar, and it'll create this lightweight little API. You can have thousands of contracts in that one little jar, and it'll spin up a fake API that returns pre-programmed responses. Your iPhone users and your Android developers and all that stuff can talk to that. All right, my friends, thank you so much for coming. Have a great day, great show. Bye-bye.